Hey guys, hello everyone. Welcome to Rasayan Academy, all of you once again. So in this video, we are going to discuss all the important questions that I had given you to solve in the previous video. I just hope that you have also checked out the PDF in the description. That those are basically short notes, and there are some really good questions which are also given with solutions. So I think that small PDF is going to help you clear your concept about the whole topic of protection and leak protection, right? So yes, let's see some of these questions, guys. First question was from June 2012. Question number one, and guys, it's very easy. Among the following, the compound that undergoes deprotection easily on treatment with hydrogen in the presence of 10% palladium charcoal to generate RNH2, that is your amine, primary amine. So see over here, guys, what do you see? First of all, it is also a carbamate. You know what is a carbamate now? This is your carboxylate group, right? Let's say this is your tertiary butyl carboxylate ester. But then now if you have a N group connected, now this whole thing is going to be a carbamate. So this is your tertiary butyl oxy carbonate. So you also call it as the protecting group. You know that already. So this is the protecting group. What do you need to do the deprotection? You need either dilute HCl. Okay, that's a strong acid, or you can take trifluoroacetic acid, which is also a strong acid. Palladium charcoal is not going to do deprotection over here. So A is wrong. What happens with option number B? This is once again a carbamate, but this is benzyl oxycarbonyl. So this is the CBZ protecting group. CBZ, that is C. You can also call it as a carboxybenzyl, right? Carboxybenzyl group, right? You can also call it like that. So CBZ protecting group is going to be cut over here. Alright, so if you just want to see where the actual cleavage is going to take place, you can see right over here. Okay, next to the benzyl carbon and the oxygen. Okay, so what is it going to give you? It is going to give us a primary amine RNH2. It is going to give us carbon dioxide and along with that CH3. Okay, so these three molecules we are going to end up with option number B. So it is generating the amine very well. What about the next one? This is only an amide, and amide deprotection will not take place in the presence of palladium charcoal or your catalytic hydrogenation. This is wrong. You have to break the amide in the presence of a nucleophile or let's say acidic solution. Last one is the F mark protecting group. I just forgot to tell you about this, but it is there in the notes only, right? So you can just check it out once. This is known as the F mark protecting group. Okay, and how is it deprotected, guys? It's very nice mechanism you see over here. The proton which is on this carbon, okay, this proton is going to be eliminated by a base. All right. So how do we write it, guys? In the presence of a base, let's say OH minus or any other strong base, what is it going to give you? It is going to give you a carbanion, and look at the electrons of the carbanion. The carbanion is extremely stabilized. Why? Because it has an electron withdrawing group, and that electron withdrawing group has a lot of conjugation. So because of this whole conjugation thing, it is a very stable carbanion which is going to fall off like this later on onto this carbon dioxide eliminates, and you are going to generate primary amine plus a carbon dioxide molecule plus a fluorine molecule. So this is what you get. It is fluorine. So what is F mark basically? That is fluoronyl methyloxycarbonyl. Fluoronyl methyloxycarbonyl. Okay. So this is the fluorine thing, and this is the methyl oxy and the carbonyl thing. Okay. So F mark protecting group is going to get deprotonated in the presence of a base through the E1CB mechanism. This has also been a question, right? Yes, very important. So the answer to this particular question, for catalytic hydrogenation, you can only break something which has a heteroatom on the benzylic position. So B is the answer. Right. Moving on to the next question from June 2013, guys. Question number 2. So what do you see over here? Reaction of S 1, 2 and 4 butane triol. So if you just want to draw one, let's say I'm having one position OH, two position I'm having an OH, three and four position I'm having a OH. Alright, so this is 1, 2, 4 butane triol. RNS I'll check later on with benzaldehyde. So whenever I told you guys, whenever you have aldehyde, it prefers to bind with the 1,3 alcohol 1,3 diol as compared to 1,2. So these two are 1,2, but it is going to prefer to bind with the 1 and the 3. So if you want to get acetal in the presence of benzaldehyde, with benzaldehyde in the presence of paratoluene sulfonic acid H plus, you will get it somewhere over here. That is the question. That is the whole thing. See, this is going to be the phenyl. Now, what is the stereochemistry that we have to determine? That is the most important thing. This carbon is right over here. Oxygen is going below the plane. The another carbon is right over here with the oxygen below the plane. Then you need to see this, that pH is going to be more favored when it is on the equatorial side and the hydrogen being axial. Why? Because here also, yes, you see that this particular carbon has oxygen below. Above there is a hydrogen. Here also, see, this is achiral, so doesn't matter, right? And you can just write this conformation like this. So all equatorial form is actually more stable, isn't it? So in this all equatorial form, we see that the phenyl, if it is going to be below the plane, then this is going to be a more stable possibility, right? I have deliberately considered, okay, I'm just writing this a little bit higher so that you can once again check the priority order and give the numbering. It is 1, 2 and 3, 1, 2, 3 and clockwise, but the hydrogen is above, so we are just going to invert it. So yes, it is S. It is correct. S. Oxygen downwards. So when this is the conformation, the phenyl has to be equatorial and it has to be below. Because if it becomes axial, there will be a huge 1,3 diaxial interaction, which we don't want. So B is the correct answer. How are you going to check for it? First, find out the RNS configuration. Then you write the chair conformation. In the chair conformation, you see the phenyl has to be equatorial. Equatorial ho to it has to be below the plane, right? So that's it. B is the correct answer. Next important question. June 2015. The major products formed in the following reaction sequence is. So you see guys, what is there in the molecule? You have the amine, primary amine and the alcohol. Bock protection, BOC whole twice. This is Bock anhydride. It is going to give you Bock protection of the amine. Let's say the amine is protected. You have NH Bock. Like this, you have protected the amine. Then you have TBSCl imidazole. So even the oxygen is protected over here, right? Even your oxygen, this is going to be protected. So I'm just directly writing, guys. You have realized the oxygen will be protected. You directly write over here without wasting any time. TBS, OTBS, like this. Now the third step is minus 38 degree centigrade के ऊपर there is a hydride donor. There is some bulky hydride donor over here, but the metal is lithium. So what are we going to be careful about? We are going to check where the hydride is being donated. Okay, that is the question. From above the plane or from below the plane, from where are you going to donate? So to remember, one important thing is that, see, the nitrogen has to be on the same side, on the same plane as the oxygen, like this. Why am I doing this? NHBOC. Because the lithium is going to do the chelation. So this is the Kram's chelation model, or you can sometimes also call it anti-Kram's rule, right? So when you rotate this, you rotate this and keep it on the plane of paper, then this alcoholic group, या फिर OTBS protected alcohol group, this is going to fall back and the hydrogen comes above. Okay, so this is how you're going to write it. And now, which is the less hindered side? Above is the less hindered side. So hydride attacks from above and you are going to have this molecule. The oxygen goes back, OH goes back, H is above. Let us write the molecule in exactly the same way. That is, see, once again we are going to rotate this because there is no configurational change. So just write it as it is. Okay, just write the molecule as it is, as it was before. So yes, there it is, OTBS. Okay, so this is your molecule. Just for understanding the chelation model, we had written it in this way. Otherwise, for comparison, the product is going to be like this. So yes, your answer should be option number C. Alright, the hydrogen, the hydride is going to attack from above. Okay, very important, guys. Next good question, June 2016, guys. Back-to-back questions are appearing in each year. Major product formed in the following reaction is. So what do you do, guys? H2 in the presence of 10% palladium charcoal. So this is only catalytic hydrogenation, but there are three protecting groups. There is this carboxybenzyl CBZ, then benzyl oxycarbonyl, that is OBN, then there is tertiary butyl oxycarbonyl, that is Bock protecting group. Who is it going to do the deprotonation or the deprotection? Absolutely, guys. Bock protecting group requires trifluoroacetic acid or a strong acid, dilute HCl, like this. Okay. However, these two groups are having the phenyl in it. Yes, OCH2PH. Yes, this whole group OBN, it is like this, OCH2PH. Okay, and what about the N? Okay, so there's this nitrogen, there's this carbamate. You are having once again the OCH2PH group, this whole thing. So as long as there is a heteroatom present on the benzylic position like this, in the presence of catalytic hydrogenation, it will be deprotected, the bond will be broken. So both of these groups are now free. You will have a free carboxylic acid and the free amine, and this group should be as it is, right? So answer is option number A. In option number B, guys, you have removed the Bock protection group. That is not going to happen. Okay, and ye dekho, CBZ is as it is, so this is also wrong. Not one of them, both of them will be deprotected because they both have the benzylic carbon. Okay, so catalytic hydrogenation works for both of them. Now look at this really important, interesting question. December 2016. So you have a big molecule over here, and this is the molecule of, let's say, a glucose molecule, right? With a lot of derivatives on it. You are having this strange molecule in the reagent. What is this strange molecule? इसका नाम क्या है? डाइसाइनो डाइक्लोरो डाइसाइक्लोहेक्साइल. Yes, देखो DDQ. Quinone type system. Okay, right. How is it going to do the reaction? Specifically used for paramethoxybenzyl deprotection. Paramethoxybenzyl ether deprotection. Okay, PMB ether deprotection. How does it do it? That's a very critical process to understand, but I just hope that I'm going to make you understand this. Okay, ye dekho, first of all, guys, first recognize which is a PMB ether. Look at this. It is paramethoxybenzyl ether. I'm saying benzyl, so that CH2PH, the CH2 group should be there over here, right? Ye kya hai? It is, yeah, look at this one. This is not benzyl because directly oxygen connected है to this phenyl ring. This is paramethoxy phenyl ether. Okay, it is phenyl because there is no CH2. This is benzyl, and ये तो carboxylate है, so let it be. Only this group is going to be eliminated. And what about the other one, CH2PH over here? No, not this one. Why not this one? Because yes, we want the paramethoxy group for the deprotection. What is it going to do? Specifically PMB ether, guys. Only for this one. ये देखो, D is the answer. Only for this one. Everything else remains the same. This group remains the same. This also and this also. Everything remains the same. Why then are we going to say that the only the paramethoxy group is going to eliminate? We need to just write few things about it. Yes. Let's see what's going on. So let's say you have a paramethoxybenzyl group in this way. Let's say I'm writing only one oxygen till now. Okay, above and below you have two hydrogens. All right, not a problem. Let's say I'm writing it like this. The DDQ molecule, guys, is going to lie flat on this molecule and it's going to form a charge transfer transition complex. Okay, so it's going to lie flat on the other molecule, the PMB molecule, like this. And how does it take the electron density? Let me just draw it for you all. ये देखो, the oxygen is going to push away the electron density like this. All right, and the bond moves apart, which is going to transfer a hydride, not just a proton, it is a hydride, to this oxygen, and the electron density falls into the ring, which is going to take away a proton from the medium. This is the only way possible that you can see that how the electron transition is going to take place. All right, so you have an OH over here. You already had a double bond. This is what you have, and this is also an OH. So this is the fate of the DDQ molecule. What happens with this one? You see, it is going to become like this, a double bond. Okay, one more double bond OMe over here. So this is what you get, right? Now water is going to attack on this molecule. Water is present over here, guys. Water ne attack kiya, and then the electron density falls back to the methoxy. Okay, and you have an OH over here. Alright, so finally the OH bond is going to break apart, and let's say ये जो oxygen था, this was coming from an alcohol ether. Okay, so that's going to free up the alcohol now, and you are going to get ROH. Okay, you are going to get the ROH, and along with that you get this molecule that there over here you are going to have the carbonyl. I just hope that you can see this. If not, that I'm trying to draw it over here. You have a CHO like this and the methoxy. So this is the mechanism of PMB ether deprotection. Not any phenyl ether, there has to be paramethoxy group. Why? Because it is helping in the hydride removal. Okay, so this is a charge transfer transition. All right, this is how it goes, and for complete oxidation you can watch till here. So this is the whole mechanism of PNB ether deprotection. That's why D is the correct answer. Now guys, moving onwards, we have one similar question asked in June 2012. It is similar but not so same. Major product A and B formed in the following reaction sequence are. So you see you have a PMB ether, isn't it? Yeah, you see that you have nothing else, only one PMB ether. Okay, and you are having one equivalent of DDQ. So the question might sound look like to you very simple, that okay, only one reagent is given and only one functional group is given. How easy? Okay, so you're going to do the same thing. You're going to break from here. You're going to uh, give the ethanol. Sorry, you're going to give the alcohol. ये देखो, you're going to get the alcohol. All right, very well. You got the alcohol very well. What is the alcohol going to do, guys? The only role of DDQ was to do the PMB ether deprotection. All right, and what are you going to do next? ये देखो, the oxygen is going to attack over the iodine. One of the acetate bonds are going to open up also. Yeah, one of the acetate has left, right? Okay. So what I do is now in the presence of methanol is a solvent. So it is going to be there all the time. Methanol is going to attack over here like this, because iodine is a good leaving group also. So methanol is going to attack over here, and then you see that OMe falls over here. Right. So what is the correct product of this reaction? Looks very similar, A and B, but yes, B is going to be the correct answer. Why? Because you have, after the PMB ether deprotection, you have just got a simple alcohol. However, this pi bond does not make any sense that why it is over here. Okay, and yes, in the overall mechanism, did you you just realize that this methoxy is going to end up over here only, and there is no extra pi bond over here, right? So B is the correct answer. Similarly, moving on to the last question for this session is December 2017 question. अच्छा, इसके बाद question नहीं आए? Definitely आए हैं guys. You're just going to open up the paper and see, right? But I'm going to make you do only these questions or any hemiacetal also. How is it going to work? It is always going to give you the methoxy ether formation on the anomeric carbon or the acetyl carbon, right? Which means, look at this. In the presence of acid, this molecule is going to eliminate water and methanol is going to attack. The same work is going to be done OMe. Okay. So the same work is going to be done in the presence let's say on the alpha position or the anomeric position of a carbohydrate, right? When we are doing the pyranoside formation, same is going to be done. Anyways, we move onwards. This is what you have formed in the first step. In the second step, you have a bulky, uh, uh, you know, reagent. So in the presence of triethylamine, that bulky reagent is only going to give you protection of the S TBDMSCl. So this is basically, you know this already. This is going to be one carbon over here, CH2, and oxygen and TBDMSCl. So I'm just directly writing. Let's directly write. There's one single bond, one more single bond, oxygen, TBDMS. Okay, connection with silicon. Alright, the last step is PDC. What is the PDC going to do? PDC is doing the alcohol oxidation. So I'm directly writing over here, this is doing the alcohol oxidation followed by acetic acid and H2O. So what is the acetic acid going to do? Yes guys, what does the acetic acid do? Acetic acid is going to, it is an acid once again, so it is going to remove this methoxy in the presence of an acid, and it is going to bring back, your molecule like this. Okay, the the acetyl position is free now. The acetyl is free now. Yes, so I just hope that this makes sense to all of you. And we have, like really good questions from protection and deprotection in this CSIR net and GATE examination papers. Please see them out by yourself. These are all easy questions. Now I'm going to see you really, really soon, all of you. And keep practicing and keep liking the videos. Bye everyone. Take care everyone, guys. And I'm going to see you very, very soon. Bye, guys.